Hi, Eduinx team.
Hi, ma'am. Good evening.
Good evening. Hi, team. So, shall we proceed?
Yes.
Just waiting for the confirmation from the Eduinx team so that we can proceed.
Hello everyone, good evening. I'm Sanjna. Before the session starts, I would like to introduce today's speaker. I would also like to extend a warm welcome to all the participants and thank you for joining us for this session. We are happy to welcome Nikita Saxena for today's guest lecture. She is a data scientist with strong experience in machine learning, NLP, and data analytics. She currently works at Infosys on global projects for Apple Incorporated, where she uses data driven approaches to solve real business problems. Her journey across roles in analytics, business, machine learning, and data science gives her a clear and practical understanding of how these skills are applied in the industry. She is also a graduate of BITS Pilani, which adds strong academic depth of her professional experience. We are confident that her session will be both inspiring and insightful, and we sincerely thank her for taking the time to share her knowledge and experience with us.
Thank you so much, Sanjana, for this wonderful introduction of mine. So, thank you everyone for joining this session, and I hope this session will help you and get you insights from the knowledge that I am having. I love to share. So, shall I proceed, Sanjana, with the presentation? Okay, so I'm sharing my screen, first of all. Just give me a minute, please, Sanjana. Excuse me, everyone.
Sure, ma'am.
Sorry for the interruption, guys, everyone. I'm just having one issue. Just give me 2 minutes. I'll rejoin and we can just proceed then. Hi, everyone. I joined back and sorry for the inconvenience from my end. There was some network issue from us, so I rejoined. So I'm sharing my screen. Please let me know if it is visible to all. Is my screen visible to everyone? Sanjana, you can. Sanjana, am I audible? to everyone.
Yes, ma'am, you're audible, but the screen is not visible actually for us.
Oh, okay. Do let me know if it is visible.
It's visible, ma'am, now. Thank you.
So sorry again, and thank you everyone for joining this session. Hope this session will help you. First, I will take you through the session, which is on real world data science project life cycle in real IT industry. So once we'll start that and we'll go through it, in the end, we'll catch all the questions related to it, right? So in this, so again, I'm introducing myself. My name is Nikita Saxena. I'm a data scientist working in Infosys. And today, let's discuss this topic, which is very like my half of my LinkedIn is filled with this question. So let's go start from this, that what student think of data science is, right? So as I mentioned that half of my LinkedIn messages are filled with this question, that what does exactly data science do on an everyday basis? So answers they expect are like building ML models and working on AI, or tuning the model to up to 99% accuracy, something like this. But the reality is something different. Okay, so in real life, our 60% or more than half percent of the time goes to the data cleaning part. Yes, data cleaning. It's not modeling, but data cleaning. I'm saying this thing because in real life industry, we whatever the data we got is never clean. Like I repeat, never. Okay, we have to deal with this missing value, the duplicates value, the wrong formats, and we have to join the different messy tables. So half of the time, like 60% goes to this thing. Now the next 20% is like business and discussion, right? Because to understand what stakeholders wanted or the upper management wanted from us as a data scientist is very important, because once we know the what the expectation is, what we have to find, what problem we are solving, only then we can proceed and go for the rest of the things, right? And explaining things whatever we finalized to a person who is non-technical is also a part of it, this business discussion. So this comes with the 20% of the time. Then that comes that where we have the next 10% is like model development, model building. So here we, yes, we do it. We, according to the use cases, we have to find the whether we are going to apply the supervised, unsupervised, or which algorithm we are going to apply. But this modeling part, which generally students think which is our all the time work, no, it is just a 10% of the work. Okay, the next thing is the deployment thing. The next 10% is like deployment and monitoring. This is important because all the modeling things is if it is done and if it is in notebooks only, it is of no use, right? Once it is deployed and like no matter how the good accuracy looks, how the good evolution matrix come, but if it is not deployed and not monitored properly, it is not no use, because then it is not giving us any output or problem solution, right? So basically data science is not just a ML uh, machine learning thing, right? It is not just that. It is like structured problem solving. So we are getting a problem, we have to structure everything, like what all things are required and what all things we are getting, and accordingly we have to get to a solution, not just a randomly blindly we are doing a modeling thing and yes, we got some 99% accuracy and we are happy. No, it's not like that, right? So today I'm going to show you that how real world data science project actually works in IT industry. So from business problem to the business impact, right? So let's move towards the next slide. And that is the reality check. Now that we understand the whole process, let's talk about whole data science flow, right? You might think that when we got a problem, let's start with the modeling thing. No, the first and most important thing is like business problem. Okay, so business problem is like for example, why are customers leaving? Like why are the revenue just dropping? Are we able to find the fraud out of it? Okay, like this of business problems come to us as a data scientist. And it is very important at that time only to like clarify all the things, because only once it is all the problems which are we have to solve is clarified, only then we can proceed, right? Which type of modeling we have to do, how we will proceed to get that all the data from separate locations, like this. So first and foremost important is the business problem. To understand the business problem by asking questions, by brainstorming sessions, like this. Okay. Then the second part comes to like data collection. Because when we are not into this data domain and we are doing some projects, we think that okay, we will get some random CSV, we will apply some data cleaning steps, and we are good to go. But this is not the case in the data science real time. Okay, because in real time we have to, there is no particular source of the data, so we have to gather from the different sources, sometimes from the like APIs, sometimes we need the customer and data, sometimes we are having data in multiple tables of the databases, like this, right? So and sometimes there are external sources from which where we have to gather the data. So it is the most important, one of the important step. Then comes to the data cleaning things, and this is the kind of part that no one talks about, that data cleaning is very important, because if we do not clean the data, so for sure our model learns the garbage, and we do not want this, right? And that's why data cleaning is very very important, and that's the only reason our most of the time or half of the time goes to this data cleaning only. Because once the data is clean, and only then we are good to go for the next further steps, right? Next steps includes the EDA. It is again very important, I must say, because before building like any model, we explore like what this data, the clean data we get, what it is saying to us. Okay, we try to answer like that, what patterns exist in this data, what trends we are seeing here, and what are two features, that are two columns, how they are related to each other, what insights they can give us, right? This all things are done in EDA steps. Okay, then it is to be said that in EDA itself, before any ML modeling, EDA steps give us the high overview of the solution, because it tells about the relation between the features, it tells about the trends, all these things. So it is very important steps. Next is the feature engineering. Okay, so this is the stuff where experience matters, right? I'm saying this thing because okay, everything we inside the high level insight we get in the EDA process, EDA step. Now feature engineering is according to the use case, what feature we have to develop or create or transform, so that the output we want, we will achieve that. So this is the feature engineering. Okay, because sometimes for example, if we are taking example of some retail domain, and we want to know that okay, we are having details of customers where last time when they purchased, so in the raw form it is of no use. But when we find that recency is a new column or new feature, where it will tell us, okay, the recency is like the last time when they purchased with us, is will tell us what is the probability that they will purchase with us in near future also, right? So all this creation of new features, or transforming the existing one, comes under the feature engineering. Okay, then the part is deployment and monitoring. this model building step, and which is very important. Like, as you all know that you are all like, okay, after being a data scientist, we will do all the model building thing. So this is the step where, according to the use case, we will find that, okay, what all algorithms we have to go with. So what is the best ways to start with the baseline model, tune it, and get the evolution matrix values. And once it is done, then we can go with the next algorithm, so that we can just compare to at the same time, right? So that we can understand. And it is not like that every time blindly we can say, oh, XGBoost is the most powerful modeling algorithm, so let's apply this to each and every use case. It is not the case, because it depends completely on the data type, the size of the data, and the problem, obviously, that which algorithm suits well. Because here we are not just doing, our motive is not to get the best metric value. Our main aim is to solve the problem, whether after applying that model, if it is solving a problem or not. Accordingly, we have to select the model algorithm, right? So then the evaluation part, where we just do not check the accuracy, because I have seen people were saying, oh, we are getting 99% of accuracy, but still it is failing. We cannot rely on just one evaluation metric, that is accuracy, right? We are having others as well, like precision, like recall, like F1 score. And we have to know as a data scientist that which to use and when. For example, there is a very basic example, that is the question even interviewer asked. Then when we are having an imbalanced data set, for that is one type of data is more in data set, then why don't you use accuracy at that time? So the answer is simple, that in that case we will not use accuracy, because there is an imbalanced data set. One type of data are more, so it will be biased, right? Output will be biased. So in that case, we will go with the either F1 score or ROC AUC score, those things. So accordingly, what is the use case, what the problem we are solving, only then we can decide which model evolution we have to select. And as a good data scientist, you should answer this thing, that which model evolution metric we are using, and why not others we are selecting. We should have that strong reasoning why we are not using others, and why we are choosing this particular matrix. Only then you can understand and think like a data scientist, right? Moving ahead, like, next step is the deployment and the monitoring part. So deployment, like, this is the step where I must say that students do not relate with. I'm saying this thing because when you are doing some project thing, okay, um, you get the data set, you data cleaned it, okay, you do the modeling thing, everything, but after getting a good evolution metric, you stop there, right? But in real life, if everything is in notebook only, it is of no use, as I already mentioned, right? So for that, we have to deploy it. And monitoring is important, because it is very true that models decay with time. Yes, because we have to, like, we cannot say, like, if we are doing modeling on this one data set, and after 3 months it will be same. No, because the reason is, user behavior changed, right? Same, the data set, the data of the customers or everything, their behavior also changed within that period of time, whether it is 3 months or 6 months. So we have to keep monitoring and keep an eye on this, whether whatever we did in the past really making sense even now, or we have to retrain, right? So these things comes under the monitoring and deployment, and which is very important, right? So, and the last is business impact measurement. And because all whatever we are doing for this step only. I'm saying this thing because after all the modeling is done, we get the good evolution metric value and everything is fine. But did we get whatever we were trying to achieve? For example, if we're trying to uh, increase the conversion rate, for example, are we getting that? Whatever the we are doing, are we getting that? If answer is yes, only then this whole process is called to be successful. Otherwise, no. No matter how good the modeling was, no matter how we did with this data cleaning part, and how we go with this monitoring and maintenance, nothing matters. If the answer is yes, we changed, we get whatever the we wanted, we solved that problem, only then this works. So this entire flow from business problem to business impact is how every real company works. Like there's the work of the data scientist majorly. So we can say like data science is not a one step process, right? It is an end to end life cycle. Okay, so let's move ahead. So here we will take, so just now we just discussed everything in a high level. Now we'll take one particular example of this, right? So this is one of the most asked use cases of the customer churn prediction, right? So what it is the use case of not only the retail but also finance background. So what is a customer churn prediction? Okay, so basically we'll start. So just think like this: you are a data scientist and working for some telecom company. Okay, and then the business team comes to you and say like, okay, we are losing customer and our churn rate is 20%. Can we reduce it? Just this, the requirement you got. Okay, the first question as a data scientist you should ask is, what is churn? How you are defining churn? We all know that churn means customer are not buying with us. This is churn. But in this particular use cases, what we are calling a churn, like if customer are not purchasing since last 30 days, is it a churn? Or last quarter, is it a churn? So all these minor details, do not assume anything. Like, okay, we know the value meaning of churn, what why to us. No, it's not, it not do not work like this. Okay, we have to be specify each and every details. Do not assume things, ask questions. And asking question is the like one of the most um, important thing of a data scientist, that we cannot assume after getting a result. We cannot say, oh, we assume this thing like this. No, you have to, once we are getting the business problem, only that time we have to ask questions and clarify each and everything in a written format, that you, the business team said that churn is if customer is not purchasing with us in next like in last 30 days or 60 days. So all these small details which you think you know, you already know, or you should know, doesn't matter here. You have to ask question, no matter how small it is, no matter how you think simple it is, right? This is a very important, though it looks not that important step, but it is very, because once everything is clarified now, till now, only then we can just move ahead to the next step. Okay, so the next step comes with the data collection and the cleaning part. So okay, so for this use case of the churn rate, customer churn, what we will do as a data scientist, we will collect the relevant data. The sources can be like transaction history, the users login history, and the customers complaint if they are having any, and their demographics, from where they are purchasing, what are their age, something like this. So here also, as I mentioned, we are not getting a single CSV, we are having a single data sheet where we are having all types of details. No, we have to gather all the things from different sources. Okay, and these all the sources that I mentioned are like, and then we have to consolidate into one place, that is a database, right? So next thing will be the data cleaning. So there, this is the where reality begins. Okay, so here we have to deal with the duplicate rows, we have to deal with the missing incomes, or the transaction negative transaction amount, something like this. So wrong format of data. Okay, so we have to deal with these things, and we have to work on that and make the data clean as possible, so that once it is clean, only then we can proceed. And it is very true to say that if we skip or do not do it properly, this cleaning thing, our model will learn the garbage pattern. This is for sure, right? The next thing is again the EDA and feature engineering. So in this case, we will start exploring the pattern over here. Okay, so we will discover for this use case of customer churn in the step of the EDA and AFI, what we will do, we discover that we discover some patterns like customer who are purchasing low, purchasing frequency are low will churn, right? Or those customers which are having problem with us, where their complaining are high, in that case also they will churn. So these are the relation we will form in this ED and API stage, right? So we can say that in this stage, even before the modeling thing, we already get the high level business problem better. We understand this thing. Okay, so now the come to the feature engineering thing. So uh, okay. So as we know that feature engineering is like, we are not using the raw data as it is. So here what we are going to use is, for example, whatever the features we are having in our data, we are going to create more according to our use cases. For example, here the for the customer churn, what we can do is we can just create new features like recency. Recency means what is the last time they purchased with us, or or the monetary value. Monetary value means in 1 month or in 1 quarter, how many amount they are spending on us. Like these value we can create so that it in future it will give us some insights, right? So this is all comes under feature engineering. Next is the model building and evaluation. So in this use case, what we will do, we will use some, there are some options for this use cases that we can go with. For example, the models are logistic, we can go with the random forest, or we can go with the XGBoost. Okay, so what we will do, we'll just split the data set into 80% training and 20% testing, like this. And I do the hyper tuning, then the evolution, everything. And the best way is to select a model, for example, logistic in this case, as a baseline model. And whatever the evolution metric value we will get, we will compare with the some advanced level model. Then we can go with the random forest or some XGBoost. So later we can decide which is performing better, and so that we can select that. So this is a way of comparing the models, and so that we can answer to ourselves and to the upper management that why we chose this particular model, and what evolution metrics we selected and why, right? So after this model, we will get what, something related to customers, that for example, customer A, the probability of getting churn is 85%, something like this, or customer B, the probability is like 15% or 10%, something. So once it is done, so then the evaluation part comes, where we just do not look at the accuracy blindly, but according to the use case, we will decide to go with which one. Because in this case, if we go with the accuracy, the churn rate is like 20, if it is 20%, so even predicting the non-churn, it will give us a 80% accuracy. So it is not no use, right? So here we will go, we can check the recall as it is mentioned here, to catch the true churners, or like precision to avoid the wasting the marketing budget. So in this way, we have to decide which metrics to go with, right? And this is where the business understanding meets statistic. Okay, so we are not blindly doing following one metric. We are have the that reasoning that why we are selecting particular metric, right? The next thing is the deployment. Now comes a very important part. We deploy the model. Okay, So after the model deployment, we generate the list of the high risk customer, and those high risk customer that can churn, that discontinue the service with us, we gave it to the marketing team, and then the marketing sends the discount offer to them, the loyalty rewards to them, or personalized communication with them, right? So in this way, we are just not doing some modeling or anything. We are solving the problem that by giving some offers to the customer who are having high rate to discontinue the service with us, we can retain them. Okay, so we are solving a problem. We are not just doing some modeling only, and it's not our task, it's the higher management task to do whatever they want to do with this data insights. No, it is our task, our data scientist task only, to solve the problem from end to end. Okay, and monitoring the steps says that after 3 months or 6 months or 1 month also, we have to keep on checking then if our model is working according to uh, what it is meant to be built for, right? Is it giving the same answers or same result that we needed? If not, if we think that no, users behaviors are changing, or people are still discontinuing our services with us even after giving them offers or loyalty rewards, then we have to think whether we have to train the model again, or we have to take the new set of data. And what we have to do, we have to just take the decision what should be the next step. So all these things comes under the monitoring purposes. Okay, and at last, the business impact, we can say that before, if it was 20% of churn, and after just doing this all targeted marketing campaigns, it reduced to some 15%. So if it is reduced, yes, in this case, it is reduced from 20% to 15%, only then we can say that all procedure we done is successful, because we got the result. Irrespective of what modeling we used, irrespective of what we got the good metric value, we did the monitoring, we got the good deployment. If the output is, for example, is churn rate is still 19% only, or 18% only, not big difference, then we can say no, it is not the right way, we did something wrong, we have to do something else, right? So that's why how we have to decide things. And okay, so let's yeah, let's move to the, so that's all about the how the in real time it works, right? How we have to follow the step by step to solve a problem, right? Next we will move to the real industry challenges. This is very important to know, because I'm saying this thing because I have seen people who are like, okay, I already did this 2-3 project on data science, I'm very comfortable, and once they started working in real time, they are like, I'm not able to do this, I'm not able to think in a specific manner, because there are still some challenges which are sometimes unavoidable, right? Which are unavoidable, and due to which we have to be mentally and ready to deal with this. Okay, so, and this is very true that no textbook can teach you these things. Okay, all they can teach you is how to do data cleaning, how to do EDA, how to do FE, that is feature engineering, or modeling, everything, but not these things. So some of the examples are like, very important is ambiguous requirement. For example, like sometimes our managers or upper management come to us and say that revenue is dropping, fix this, or something like customers are not happy with this, what to do, or dashboards are not doing great, fix this. So these vague problems, it sounds vague that there is no context they gave us, no data they gave us, they're just randomly saying this thing. But we as a data scientist have to think like that okay, if dashboard is not working fine, what can be the issue? Okay, and why it is he's saying that it is not working, or what metrics he's taking, And so we have to think in a specific way to convert this vague problem into a solution, right? That's the data scientists do. The second thing is like stakeholders like pressure. Then this is very real, because we think that okay, we know all the steps, we have to start with a business problem and then we will go with the monitoring and deployment. But sometimes it's they are like the upper management pressurize, like okay, we have to complete it by next week or in 5 days something. So at that time we have to um, we have to communicate them very well that okay, this is the process we are going to follow and it will take some time, and for testing also we need some time. So like this we have to communicate to them like what we are going to do. And there are also cases where they will ask like okay, let's work on AI on this use case. But you as a data scientist should know that when to use which thing, because nowadays it's like a buzz, like everyone wants to use AI. But still we are doing there are cases where we are using just normal ML models, like, and it is doing well. So you as a data scientist should know that where to use the ML algorithms, where to use the NLP, that is the natural language processing, where to use the deep learning, or where to use the AI thing, so that you can communicate to the upper management or the stakeholders why you are using it, and why are you not opting other options, right? In that case communication is very important. And sometimes it is a case where you have to explain everything to the non-technical person, so that also comes under this stakeholder pressure thing. Okay, next is dirty data. As I already mentioned, that dirty data is reality. We are not getting all clean data at once. It takes so much of our time to clean the data as a data scientist. And sometimes, yes, more than the half of the time goes to this process, this step. And another challenge can be like last minute changes. For example, and this is the reality, right? For example, we are done with all the modeling, we are doing the evolution matrix, and suddenly the requirement is like okay, data scientist, we are not going to analyze overall, now we need a region wise analysis. So for this also we have to go back and make all the changes accordingly, right? So this is the real industry challenge. So let's go towards the next, which is the essential skills for the success. So we understood all the things related to the data scientists, what they are doing, how they should proceed. But again, the question is from where we should start, right? When it comes to the technical skills, I think most of the people know what should we do. Like Python, we should know, the SQL we should know, right? Let's talk about the Python first. So Python is a must for coding, I must say, on a large scale. But uh, if we talk about the interview process, easy to medium will be fine. If we know the Python core, it is fine, right? And pandas and NumPy basically we need to for the data cleaning purposes. But when it comes to the SQL, as I mentioned, if you are in any position or any designation in data domain, whether it is business analyst, data analyst, data scientist, or data engineer or ML engineer, you should be pro in SQL, because all we are getting is data, and data is stored in tables of databases. And if we want to interact or communicate with the data, we are writing the SQL queries for that, right? So that's why SQL is must. So if you want to crack any interview in any data domain, you should practice medium to hard level of SQL queries. Okay, the next thing comes like ML framework. So ML, it comes like with ML algorithms, all the supervised, unsupervised algorithm, then evolution matrix, then hyperparameter tuning, the cross validation, all these things comes under ML. Now if we talk about ML frameworks, so if we are using the like scikit is the, if you are using the NLP or the deep learning, then TensorFlow is one of the framework you should know, right? Then the statistic is like must. It is the backbone of the data science, I must say. I'm saying this thing because I have received the messages where they have people have started doing ML things and didn't do not know anything, the maths behind the algorithm. So this they cannot explain the algorithm into the interview or in the real work if they do not know the maths behind how ML is, that algorithm is working. So it is useless in that case. That is the reason a statistic is a must. Like all, there are not much topics, but all these topics you should know very well, especially the maths behind each and every ML algorithm. Okay. And cloud platform is like one of the optional, I must say. It is not necessary in the starting, but yes, if you are into this, it is into this domain only, later you will need this cloud platform, either AWS, Azure, or GCP, something. Then we have to come to this non-technical skill, because this is the skill that most people ignore. Okay, they do not take it seriously. The first is communication and presentation. I'm saying this thing because half of the data science works depends upon the communicating, either asking questions or presenting the insights to the upper management. Okay, and that's where the communication is very, very important. If you do not ask the question, just assume it will not going to help. Okay, or if you are not, if you are very good at modeling, you did every research, you get the whole insight, but you are not able to present whatever the insights you have found, so another person will come and present your insights and take all the credit, right? That's the reason as a data scientist you should be very good at communication and presentation, right? Then business acumen. It means if we are going to work as a data scientist in some particular field, for example, retail or finance or healthcare, something, you have to know the basic working or basic terms behind that field. Okay, you cannot, if you're, for example, if you're working in um, for example, fintech, okay, finance background, you cannot say that I do not know conversion rate, what is that, or some basic terms, right? You cannot just say that I don't know. You have to have basic terminologies or basic knowledge of that background, so that when you work on it, you understand it properly, what the requirement is, what I have to ask, what I have to solve, these things. Then coming to the problem solving. Problem solving is all we as a data scientist are doing, right? As I mentioned earlier also, that everything is zero if we are not solving problem even after getting good evolution metric. So problem solving and thinking in a way to just divide the whole problem into modules and think that, okay, what we have to do, if this fails, what alternative we can do, think in a like this, start thinking like this. Okay, this is the good, very good skill. And then it comes to the critical thinking. And I'm saying the critical thinking is a non-technical skill that differentiate you from a good data scientist. I must say this thing. What comes under critical thinking? Okay, for example, we get everything right. Okay, uh, all the metrics are good, all the deployment seems good, but suddenly two features, two columns value are not seem good. So like by seeing the data, you should say it is not right or it is not practically true, something like this. Okay, so you have that sixth sense, or not sixth sense obviously, but that thinking of future also, that this cannot be that value because in future this will create this issue. Even after it is showing, it is looking good on paper, but you have to double check on this thing, that whether it is good, or this good value in the on the paper, will it really work, thing like this. Okay, always double check on your data what you get, and always question that will it work, and is it looking good on realistic manner. So this is the critical thinking. It comes with the seniority, obviously, but start thinking at least, right? So as I mentioned, data science is about solving business problem, not just building models. And the best data scientists are equal parts technical expert, business consultant, and communicator. So that's all about. Awesome. Thank you, everyone. So any open for questions, if any. Sanjana and team or everyone, we can discuss if any questions are there.
Nikta, thank you for wonderful session. I don't have any question right now.
Hope this session helped to understand what exactly we are doing and how to proceed exactly, right? What all the steps, not only the projects we are focusing on by seeing some YouTube channels or YouTube videos. It is not like that. In real time, we are facing different issues. We have to handle the different use cases, and all the scenarios are different from what we get. So yeah, I just tried to give you overview on that. Hope it helps.
Yes, sure. Thank you.
Yes.
To conclude, we sincerely thank Nikita Saxena for an insightful and engaging guest lecture. Her practical examples and industry experience made the session very valuable and inspiring. We also thank all the participants for their active involvement and interest throughout the session. We truly appreciate the time and effort taken to make this lecture a success. Thank you, everyone. Thank you, ma'am.
Thank you, everyone, for joining. And thank you, Sanjana, for. Thank you so much.